Yes, this is Unit 15, Lesson 3. This is about arc length, sector area, and segment length. So what we're going to do is, as usual, the first thing you need to do is to get yourself a piece of paper or something that you can write on and something to write with so that you'll be ready to write down any questions that you may come across as you watch this video. Okay, so we start out with the usual thing with definitions and such. So the arc length, as we've already talked about some of these things, arc length is actually the length of the distance between the two bounding sides of a sector that is part of the circle. So it will always be proportional to the circumference of the circle, and if the measure of arc AB is the measure of the arc in a circle with radius r, then the arc length of arc AB is given by this formula right here. Arc length of AB is equal to the measure of the arc AB divided by the total circle, which is 360 degrees, and all that's multiplied by the circumference, which is 2 pi r. Okay? And this is what they're talking about. The distance from B to A, or A to B, whichever way you want to look at it, is bounded by the radius from the central angle on both sides. So this gives us a way to figure out what that is. Okay, examples 1 and 2. Okay, what they want us to do here is they want us to find the length of arc AB. So what we're going to do is take a look at our diagram. So in this case, the angle that subtends the arc called AB is 60 degrees and has a radius length of 5 centimeters. So we're simply going to plug it into our formula, which said that you take the angle of the arc section or the sector, put it over 360, which is the whole circle, so 60 over 360 times the circumference, which is 2 pi r, equals 1 over 6 times 2 pi times 5, which is equal to the arc length of arc AB. Okay, so the arc length of arc AB is 1/6 of 10 pi. So we multiply that out. That gives us that the arc length of arc AB is approximately 5.24 centimeters. Okay, example 2 says they want us to find the length of arc AB in this circle. Okay, this circle has a different measurement. Notice that the radius here is 12 feet, and they didn't give us the angle that's for the minor arc, which is what we're actually looking for, but they gave us the major arc angle, which is 240 degrees. So to find the minor arc angle, we simply take 360 minus 240 is equal to 120 degrees. Then we plug it into our formula, so the arc length of AB is going to equal 120 over 360 times 2 pi times 12 is approximately 25.13 feet. Okay, so let's look at some more definitions. In this case, they're talking about a sector. The sector of a circle is a fractional part of the circle. It is the area bounded by 2 radii and an arc. Very simply, it's a slice of the pie. When a bounding arc is arc AB, the area of the sector is given by the area of the sector is equal to the measure of arc AB divided by 360, which is the whole circle, times the area of the whole circle, which is pi r squared. Okay, and this is what we're looking at. Once again, it's very similar, but this time instead of worrying about the length of the distance between, or the circular distance between A and B, what we're actually looking at is how much space is being occupied by the sector. Okay, so they want us to find the area of this shaded sector. So here's what we've got. We've got this angle of 60 degrees here at the center. And so we have a radius of 4 yards, so we simply plug it into our formula, which says the area of the sector is equal to 60 over 360 times the area of the circle, which is pi r squared. So this gives us 1 over 6 times pi times 4 squared. So the area of the sector is equal to 1/6 of pi times 16, which is approximately 8.38 square yards. Okay, example 4, they want us to find the area of this shaded sector. Okay, notice this time they gave us the arc of the minor sector, and they want us to find the area of the major sector. So the first thing we got to do is find out what the arc measure is of that. So we take 360 minus 120, so that's what we put over 360, times the area of the whole circle, which is pi r squared, which reduces to 240 over 360 times pi 6 squared. So the area of the sector simplifies to 2/3 pi times 36, which is approximately 75.40 square feet. Okay, some more definitions. This time they're talking about a segment. Okay, the segment of a circle is that portion of a circle bounded by a chord and its associated arc. And it's only meaningful to speak of segments whose bounding arc is less than 180 degrees. Okay, so here's what a segment is. This is the shaded area up here between the chord and the arc. And what we're going to do is find the area of the segment. You find this by subtracting the area of the triangle that's formed by the segment's chord and its 2 radii from the area of the sector. So you find the area of the sector just like we did before, and we subtract the area of this triangle away from it. Okay, so find the area of the shaded segment. Okay, so here we have a triangle. Actually, we have a sector that has a triangle drawn across it because they drew a chord across from the 2 radii, and they're telling us that this major arc here is 270 degrees. So the first thing we need to do is to find out what the angle is inside this triangle at the center of the circle. Okay, so that gives us 360 minus the 270. It gives us 90 degrees. So we know this is a right triangle. So that's going to make it simpler when we go to find it, because it's going to be 5 times 5, and half of that is going to be our area of the triangle. So here's what we got. The area of the segment is equal to the area of the sector, which is the previous formula we just talked about, which is going to be the angle at the center here that forms the sector. So this is 90 over 360 times pi r squared, which is the area of the whole circle. And then that's going to be minus 1/2 5 times 5, which is 5 squared. Okay, so our formula comes up as 1/4, because that's what 90 over 360 reduces to, times pi times 5 squared minus 1/2 times 5 squared. So this gives us 25. When we factor the 5 squared out of both of these, gives us 25 times 1/4 pi minus 1/2, which gives us approximately 7.14 square inches. Okay, example 6. This time they want us to find the measure of arc ADB. Okay, here's what we've got. We're told that this arc from A to B is 7 pi inches, and that is a minor arc in the circle. So the first thing we got to do is to determine what portion of the circle we have here. So arc ADB, arc length, is going to equal to 2 pi r, which is 2 pi times 19 in this case, minus 7 pi. Okay, so this gives us 2 pi 19 minus 7 pi, gives us pi times 38 minus 7, which is pi times 31, which is approximately 97.39 inches. Okay, this concludes our lesson on arc length, sector area, and segment area. So once again, if you've written down any questions or if you have any questions that occur to you, be sure you get them asked tomorrow before we start any work on this lesson. Thank you very much. Goodbye.